Assalamualaikum Azwar. Hello.
Ya, Waalaikumsalam. Sekejap.
Ada tak dapat WhatsApp saya?
Ada.
Fazlin. Macam tak ada orang je ni. Pukul 10 nak start ke nak tunggu dulu?
Up to you.
Ha?
Up to you.
Kita tunggu sekejap
Okay.
Assalamualaikum and good morning, everyone. Thank you for your participation in this faculty open day. So, inshallah, we'll start in 5 minutes time as we are still waiting for more participation. So, very much for patience. Okay. Okay, Assalamualaikum warahmatullahi ta'ala wabarakatuh and good morning to all. Welcome to the virtual open postgraduate day for Masters in Molecular Informatics. My name is Zafira Liana. I am the moderator for this session. Ladies and gentlemen, for your information, this morning's session is the part of the virtual open postgraduate day for master's program mixed mode organized by the Faculty of Pharmacy. In this primary session, we will introduce you to the first of its kind offered in Malaysia, which is the Masters in Molecular Informatics. You'll be hearing presentation from two speakers, which is also the teaching members of this program. They are Associate Professors Dr. Fazil Muhammad Fauzi and also Dr. Ruzan Isra Muhammad. During this session, you will be introduced to the molecular informatics field and briefing on the program structure itself. Last but not least, we will have a Q&A session at the end of the talk. However, you can drop us the questions in the chat box at any time, and we will answer the question at the end of the session. Also, we appreciate if you could fill the feedback and also attendance form, which will be provided at the end of the session. Ladies and gentlemen, I am sure many of you are curious about what is molecular informatics and the importance of this field. Now, without further ado, let us call the expert itself, Associate Professor Dr. Fazil Muhammad Fauzi, to brief us about what is molecular informatics. Please welcome.
All right. Thank you so much, Zafira, for the very kind introduction. So before I start, I'll just share with you one slide that I have that is hopefully good enough to explain everything. All right, so my purpose for this morning is to give a brief overview on what molecular informatics is. So what you'll find people in this field doing is what you see on the screen right now. We're just in front of the computers, typing away, coding away. But of course, there's much more to it than just writing lines of codes and analyzing millions of data points, thousands of data points. So I'll start off with this article from the Washington Post, which was posted last week, August 5th, which kind of, in a succinct way, explain what molecular informatics is about. So molecular informatics is basically drug discovery using artificial intelligence. So why it's called molecular informatics? I think several years we want to differentiate between computer science and the different field where computer science is applied. For example, in drug discovery, molecular informatics, and you have health informatics where you apply artificial intelligence in healthcare settings. So in this Washington Post article, it argues that drug discovery is about to get faster thanks to AI. So just imagine a few years back, a few decades back, that if you were to make a decision based on 10 drugs, you can do it alone. But how significant would that decision be if your point of references is only based on those 10 drugs or 10 data points? Currently, we have millions of data points. So how do you analyze or make decision based on that thousands of data points? We only have so much time and so much capability to process and analyze those data points. So this is where artificial intelligence comes in. So what is artificial intelligence or AI? I'm sure you've heard a lot of this catchphrase in the media, in news articles, etc. So artificial intelligence is basically using machines, software or apps to do tasks that requires human intelligence. So in my example previously, we talked about making decisions based on data points, millions of data points. So again, if you were to only make it, if you were to decide based on 10 data points, you can do it yourself, but how significant would that be? The more data points, the more evidence that you have that you make your decision based on, the more significant your decision would be. So this is where AI or artificial intelligence comes into the picture. So in terms of in drug discovery, what are we trying to learn at the same time solve? So of course, this is a very simplified version of what we're trying to learn or solve. It's what we call the magic triangle. So in this magic triangle, you have three different domains. You have the chemistry or chemical structure depicted by the chemical structure. You have the biology part, which is depicted by the structure of the receptors, and you have the outcome or phenotype, which is depicted by the human body here. So just like in pharmacy, we're always trying to figure out the effect of the drug in the human body. So the drug enters the body, it interacts with the specific receptors or enzymes to produce an outcome. So those are the things that we are trying to understand and also solve at the same time. Of course, this is much more complicated than that. There's layers in each of the domains. In chemistry, how do you make decisions do you do it based on the 2D structure or the 3D structure? And there are multiple ways where you can look at a structure from a 2D point of view or 3D point of view. In terms of receptors, you have receptors, subreceptors, and then also the interaction of those enzymes and receptors. Do they interact in isolation? If they trigger another protein receptor, would that produce the outcome? Or if another receptors kind of interact with that receptor, would it produce a bigger outcome, or would it cancel each other out? So there are much more layers to each of the domain. Even so, we always believe that the drug would interact with the receptor and it produces an outcome, but it's not usually that straightforward. Sometimes it has to interact with multiple receptors. Also, sometimes it does interact with the receptor, but it's not enough that it will produce the outcome that we're trying to, that we are interested in. So again, in essence, we're trying to learn and solve the magic triangle issue, but under each of those domains, there are multiple layers. Right. So how do you apply all this AI or machine learning in the drug discovery process? So this is a figure recently published in Nature Review Drug Discovery. Again, this is a very simplified version of what actually happens, but at least it gives you kind of an overview of what happens. So if you see the analyze and test, so again, we analyze thousands, sometimes millions of data points, and then we produce kind of like suggestion on what to test, why you should test it, and etc. Then we can go further by learning from previous experience to now looking to the future. So based on those data points, based on our analysis, what can we do? What new things that we can do? So in this case, design new compounds, make new compounds, and then using that to produce drugs, produce new medicine. So actually, we are already part of the ecosystem of, we are kind of part of the AI revolution in the sense. So if you have one of these devices, so your fitness trackers, it uses machine learning to first collect the data points, and then from those data points analyze, and then kind of suggest what you can do given a specific problems. The other one is your emails. Emails is usually what I use to kind of explain in the simplest way what AI is about. So if you notice in your emails, those emails that you deleted, and then you check again your spam folder, you'll see that those emails that was sent in later dates was automatically deleted. So this is where AI kind of does what it does. So your Gmail, what it does is it studies your clicking patterns. So which are the emails that you deleted, which are those that you open, which are those that you don't open but you retain in your inbox. So when new emails come in, Gmail knows whether to retain it in your inbox, to put it in your spam, or sometimes lately you can see there is a suggestion you haven't opened this email and you haven't replied to this email. Do you want to do so? So those are the kind of things that AI is responsible for. Another thing that if you ever notice that if you click an article on Google or other news outlet, and then you see similar articles being given to you on your Instagram, on your Facebook. So again, that's where AI comes into place. They study those data points and then make suggestions. So it's the same in drug discovery as well. We study previous data points that are available, and then from those data points make decision on what to create, what compounds that we need to go, that should go through to the next level and which we should just completely abandon. So just keep in mind, those are the kind of AI technologies that you are currently using, and also can be applied in a drug discovery setting. Right. So what's next, basically, in the pharmaceutical industry? So we talk about drug discovery. Right now, we're also looking at diagnostics. So basically using AI to diagnose a certain disease. So for example, if you have an X-ray of someone with pneumonia, you probably find kind of like a white plaque, kind of white cloud on the X-ray of the lungs. But if you were to give that to 3 different doctors, those 3 different doctors may have different diagnosis. So the first doctors may say, yes, it is pneumonia because it has that white cloud on the lung. And the second doctor would say, yes, it has that white cloud, but it's not big enough to diagnose it as pneumonia. And then you have another third one who says that, maybe both of them are right. So with the use of AI, what you can do is kind of standardize. So put aside the human perception, we calculate certain parameters, and then from there you can diagnose in a much more accurate way. So you reduce the false positive, reduce the false negative. So then you won't kind of create that problem of someone who was overdiagnosed or someone who were misdiagnosed. So with this kind of technology or approach, we can standardize all this and then put aside the human perception so it can be much more accurate to reduce false positive and also false negative. All right, so my last kind of outtake from this is, so instead of telling you why you should join the program, I'll tell you why I am in this field, and how it has been for me. So I think I've been in this field just over 10 years, 7 years as PI, and then 4 years as a student studying in this field. What I found was that being a pharmacist provides a unique insight and perspective in this field, because I have that kind of advantage of knowing how the drug works or how it is being used in a clinical setting. So when it comes to research, it's much easier to recognize what problems should be solved and also how applicable is the solution that we are providing. So I do find that being a pharmacist and doing this and being in this field does provide a certain advantage that you might not get if you're just a computer scientist or a pharmacist, on its own. So this is a quote. There was a TV series a few years ago called Suits. In the first episode, Rachel said, research is as much art as it is science. So this is very much true in this field because there's a lot of creativity that is involved in this field. Creativity in terms of finding new ways to solve the problems, new ways to see the solution and all that stuff. And then you have different AI approaches. So which one should you use? And sometimes you can use it for a different problem as well. So I do enjoy the creativity that I don't think I would get as much if I was a practicing pharmacist. Not that being a pharmacist is not fun, but if you are a creative person, in terms of finding creative ways to solve a problem, then I think research might be something that you should consider. And lastly, research is a long game. Things that you do in research is long term. The problem doesn't solve straight away. It's solved by stages. Just like the magic triangle that I explained previously, there are layers to each component of the magic triangle. So it's the same as research. It's a long game, even if it involves computational work. I know it sounds counterintuitive with the first article that I showed you. Drug discovery does take a long time, but with the use of AI, it does reduce it a bit. Hopefully in the future, it would reduce it much more. As I said, it's a long game, so you can't expect it to reduce by half immediately. It's bit by bit, step by step. All right, so that's it from me. I hope I've provided a simplistic view of what the course is about, and I hope that you'll consider this course in the future. All right, thank you, and I'll hand it over back to Zafira.
All right, thank you very much, Associate Professor Dr. Fazil Fauzi, for the overview about what is actually happening in the molecular informatics field. And I'm sure many of us has gained some insight about this field. And I hope that everyone has started to type about molecular informatics on the Google search tab. Okay, so next we have Dr. Ruzani Isra Muhammad. So she is the coordinator for this master's program. So I would like to welcome Dr. Ruzani Isra Muhammad to brief us about the program structure itself. Please welcome.
Assalamualaikum and good morning, everyone. My name is Ruziani Isra Mohammed. I'm the coordinator for PH773, MSc in Molecular Informatics, and this is the information about program structure, and this is for 2023 intake. So this year we didn't open for any admission, but for 2023 we will open, so that this is the introduction about the course, about the programs. So this is the outline about the discussion or the introduction. Today, I will give some course information, course introduction, program educational outcome, curriculum structure, opportunities and facilities. PH773, MSc in Molecular Informatics. This is a mixed mode, 30% talk and 70% research. For the full time, it will be 1 year, and then part-time, maximum 4 years. And the credit hours is 40 hours. And our location is at Faculty of Pharmacy, UiTM Selangor branch, Puncak Alam campus. As you can see in the table here, the mode is full-time, 1 year for 3 semesters, and maximum is 2 years for 6 semesters. And if you're doing in part-time, minimum is 2 years, 6 semesters, and maximum 4 years with 12 semesters. This is the admission requirements for the current admission requirements, and we will change this one to new admission requirements. At the moment, we accept students from bachelor's degree in pharmacy with CGPA 3 and above. And then for the English, we need to reach IELTS score 6.5 and above, or TOEFL score of 550 and above, or MWET band 3 and above. And then any other qualification approved by the UiTM Senates from time to time. And for the new admission requirements, we will put in our website later. This is the course introduction, as mentioned by the Associate Professor Dr. Fazil Fauzi. Just now, the program covers the field of chemoinformatics and bioinformatics in drug discovery research. Both approaches can be used to translate data into information and knowledge. The information generated can be used to address drug discovery problems, such as finding a better drug safety profile. This is the program educational outcome. This program will produce pharmaceutical data scientists that apply knowledge critically to manage and resolve issues in drug discovery. demonstrate the ability to critically assess relevant information, to develop alternative perspective and solutions, demonstrate practical, numerical, and digital skills in solving drug discovery problems while displaying good leadership, communication, interpersonal skills, autonomy, and independence. Integrate personal development with entrepreneurial skills effectively to advance the field of computational drug discovery and professional and ethical in handling issues related to drug discovery. The curriculum structure, as you can see here, for the semester 1, we have Chemo Informatics Theory and Application, 3 credit hours. Bioinformatics Theory and Application, 3 credit hours. Machine Learning in Molecular Informatics, 2 credit hours. And Research Methodology, 4 credit hours. Depending on the student background, they will also undertake either life sciences or computer science module. If you are taking life sciences module, it is Principles of Pharmacology and Medicinal Chemistry, 3 credit hours. And for the computer science module, you are taking Bioinformatics Programming. This is for the semester 1. And for the semester 2, we will have Data Mining and Analytics in Molecular Informatics, 3 credit hours. Industrial Attachment, 6 credit hours. And Postgraduate Seminars, 6 credit hours. And for the last semesters, semester 3, we have dissertation with 10 credit hours. I will go to some synopsis about each of the course. For example, this one, Chemoinformatics Theory and Application, creative application of big data, analytics in chemistry that enable chemists to gain insight on drug discovery question, such as what structural features a specific protein target recognized. This course introduces students to the different ways chemical structure can be transformed into format readable by computers and consequently the different ways these data can be manipulated for the purpose of drug discovery. As you can see here, this is computers. That means that we use computer to translate the chemical structure into readable formats, okay? And additionally, this course covers the application of 3D, three-dimensional protein structure in biology, pharmacy, and medicine. Students will learn the theory and methods of comparative modeling, such as homology modeling, implementation to the build protein structure, and infer the structured data to the protein function and related diseases. And this one, student can learn about the protein structure in a deep format, okay? And then we have bioinformatics theory and application. This course covers fundamental of sequence analysis, like multiple sequence analysis, genome assembly, high throughput transcriptional profiling, system biology, phylogenetic algorithms, and introduction to the power of bioinformatics in modern biology. And then we have machine learning in molecular informatics. The course introduced the fundamental concept of machine learning techniques such as SVM, KNN, random forest in bioinformatics. The objective is to familiarize the student with the basic machine learning algorithms and their application in analyzing large biological data set and perform predictive analytics of big data. The course covers the ongoing developments in deep learning with the focus on the application in the life science data. The use of the respective method to solve problems in bioinformatics is explained in this subject, and we are using primarily the R scripting language. And the next one, this is at semester 1. This is the principle of pharmacology and medicinal chemistry. Student will learn. This course provides students with the knowledge of chemistry. They are relevant to the study of pharmaceutical drugs, for example, stereochemistry, psychochemical properties, drug target interaction, Additionally, process of drug discovery, rational drug design, and overview of the structure-activity relationship of certain drug classes will be covered. And then if you are using from the life sciences module, you will take bioinformatics programming. This is basically programming, and then we are using Python. Yeah. This objective for the course is enable students to use Python to work with massive biological data and solve fundamental biological equation. And the next one, at the semester 2, students will learn about data mining and analytics in molecular informatics. The course introduces students to the concept of data mining and predictive analytic skills in analyzing big data problems. And the objective of the course is to encourage the development of analytic skills essential to discover patterns and new information from data and help students develop effective strategies for solving problems. And the next one, we have industrial attachment. This will take 6 to 8 weeks. The student will be trained at research centers of pharmaceutical industry, and they shall be imparted with knowledge on drug discovery process in an industrial setting and how molecular informatics play an important parts in the process. Additionally, students will also be exposed to other components of pharmaceutical industry such as leadership and business management. And then the last one, student will go to dissertation. The individual project provides experience with solving drug discovery related problems using chemoinformatics or bioinformatic approaches. Students will therefore develop their understanding of relevance area of chemoinformatics, cheminformatics, and bioinformatics, the capabilities in the practical works and writing activities involved. Okay, this is the last one at the semester 3. And now we go to opportunities. Besides having experts in our faculties, we will also invite lecturers, expert in molecular informatics, cheminformatics, chemoinformatics, and bioinformatics from local and international universities to conduct the lectures too. And then for the industrial attachment, we will prepare or we will have list of the local or international industries or institution related to our area so that student can choose which industries or which institution that they can go and do their industrial attachment. And also we will give some suggestion or give some information about scholarship. What kind of scholarship student can apply before they embark to this program, such as maybe we can apply for Mara scholarship. And then for the research, at Faculty of Pharmacy, we have many best researchers and well-equipped laboratories, for example, wet lab, so that beside doing in silico, we also can collaborate with our researcher at Faculty of Pharmacy. And then we also can have a collaboration in research for the local and international partners, university or industries. Okay, this is the opportunities that students can have when they embark for this program. And facilities. Once you are a student for this program, you have the full access to our facilities. Okay, before that, where we are here at UiTM Puncak Alam campus, and it is about 1.5 hours from Kuala Lumpur if you're from international student. And then this is the main building for Faculty of Pharmacy. As you can see here, you can see FF2, FF1. Okay, and then we are here actually at level 8. We have 2 computers lab here. And then this is our molecular informatics and bioinformatics computer lab. You can use all the facilities here. And then you can also go to the library. This is PITA at UiTM Puncak Alam. This is really amazing and nice library. And this is our smart classroom at Faculty of Pharmacy. If you want to use this room for your discussion, or you can have online meetings with your international partners or outside people, you can use this smart classroom. Just let our ICT person know, and then you can have the access to this classroom. And this is the postgraduate lounge at our lab, so that you can use this area for your discussion and to have a break here. Okay, and remarks, yeah, for the admission procedure or English proficiency or fees, etc. Please refer to this IPSIS. You can click this one, and all fees, charges, and accounts will be payable in advance as determined by UITM from time to time. Students will not be permitted to commence or continue their studies at beginning of any semesters until all outstanding fees, charges, or accounts are paid. Okay, for the fees, please contact IPSIS, and UITM reserve the right to vary its fees at any time. So, as for your information, UITM charge the lowest among the lowest tuition fees in Malaysia. So, and the last one, if you have you want to get more information or further information, please go to this website, to IPSIS website, and to our Faculty of Pharmacy's website. You can go to under program menu. Okay, and you can also call us at office hours, so that if you have any question regarding this program. Okay, thank you. If you have any question, you can let us know. Okay, thank you, Madam Zafira.
All right, thank you very much, Dr. Rizanistra, for the briefing of the program structure itself. Okay, so we open the session for any questions from the members of the floor. You can also drop us the question in the chat box. All right, I just posted the link for the attendance and response feedback form. So I hope that everyone who participates could fill in the forms and submit it to us right away. Okay, any questions?
If you have any comments, you can write at our Google Forms, so that we capture your email, so that we can send you any updates or information regarding this program later.
Yeah. So is there any questions, any comments you would like to know from us about this program? Please let us know. All right, I'm sure everyone will respond in the feedback form. Okay, so thank you very much to Dr. Ruzanisra and also Associate Professor Dr. Fazin Fauzi for giving us the briefing and overview about this program. To all participants, thank you very much for joining us in this event. Okay, I hope potential candidate who participated in this event, in this morning session, could put in your application for 2023 application, Master in Molecular Informatics. And we really appreciate if you could pass this information about this program to others as well. All right, so if nothing else, I think we can end this session now. Thank you very much, everyone, and Assalamualaikum.